this page has a bunch of systems of linear equations. Problem number 1 has 3x plus 2y equals 7 and y equals 3x minus 2. So this problem is begging for substitution. 3x plus 2 times y is equal to 7. Y is the same as 3x minus 2. Therefore, 3x plus distributive properties, 6x minus 4 equals to 7. Collect like terms and add 4 to both sides, and it looks like 9x equals 11 and x equals 11 over 9. Now that we have this solution, we can use the bottom equation to figure out what is y. Y equals 3 times x minus 2. X is 11 over 9. Let's see, 3 times 11 ninths is 11 thirds, and 2 is the same as 6 thirds. So it looks like y is coming out to be 11 thirds minus 6 thirds, which is 5 thirds. So it appears the solution here is 11 over 9, comma 5 over 3. For the second problem, we have 4x plus 2y equals 10 and y equals negative 2x plus 5. This problem also looks like a substitution problem, so let's attempt it. 4x plus 2 times y is equal to 10, but y, of course, is negative 2x plus 5. Distributing 4x minus 4x plus 10 equals 10. Canceling out the 4x's yields 10 equals 10, which is an identity, right? 10 is always equal to 10. Therefore, these were in fact the same line, so when we write up the solution, we need to indicate that there were infinitely many solutions of a particular form. So that would be the set of xy, such that I'll write the top equation divided by 2, so it's in its simplest form. 2x plus y equals to 5. So that is one way of writing up infinitely many solutions with the standard form of the line as the condition. In the third problem, down here in quadrant 3, we have 3x minus 7y equals 5 and 5x minus 4y equals negative 3. So to get my x coordinate, I will take the top equation and let's multiply that one by negative 4. So I'm getting negative 12x plus 28y multiplied by negative 4 gives me negative 20. And on the bottom equation, I'll multiply by 7. 5 times 7 is 35. Negative 4 times 7 is 28. And negative 3 times 7 is negative 21. Eliminating, since those match up, leaves me with, let's see, 35 minus 12, which is 23x, equals negative 41, and therefore x equals negative 41 over 23. On the other hand, I'm now going to do an elimination on the x variable. So I'll take the top equation and multiply by 5, 15x minus 35y equals 25, and on the bottom equation I'll multiply by negative 3. Negative 15x, negative 3 against negative 4 yields 12y, and then negative 3 against negative 3 yields the number 9. So now, when eliminating, the x's are canceled, and I'm left with negative 35 plus 12, that's a negative 23y, and then 25 plus 9 is 34, so y equals 34 over 23 negative. So the final solution appears to be negative 41 over 23, comma negative 34 over 23. And finally, for the problem over here, we have in part D, 6x plus 4y equals negative 7, and 9x plus 6y equals 5. Let's multiply the top equation by 3. Multiplying by 3 yields 18x plus 12y equals negative 21. And then I'll multiply the bottom equation by negative 2. So I'm lining up those x's. Negative 2, negative 2, negative 2. Notice this time when we add, both of the variables are gone. So on the left-hand side, we're left with 0. And on the right-hand side, we get negative 31. 0 never equals negative 31. So here we'd say that there is no solution to this particular system of equations, also referred to as inconsistent.